Okay. So number one, pretty straightforward. It's telling you that it's the diameter, so you're actually going to use that number, and then they're telling you to use 3.14. So you should have B for number one. Any questions about that one? So now taking a look at number two, they have a diagram. And again, when it says consider, you want to take a look at it just to see what you already can figure out about the picture that they're showing you. So it says, consider this circular park below. So now it's telling you that it's a park. You've got an entrance and you've got a fountain. And you can tell from the entrance to the fountain that it's a diameter. So it says one path leads around the border of the park and another path leads straight through the center. The path through the center from the entrance to the fountain is 800 meters long. How much longer to the nearest meter is the path from the entrance to the fountain by going around the border of the park? Use 3.14 as an approximation for pi. So we're still in talking about circumference. So what do you think you have to do with number two?
Pi times 3.14 times 800.
Uh-huh.
And then I guess you subtract 800 from the answer.
Very good. So what answers did you come up with?
Okay, I actually just, because I only did the circumference, and then when you just read it, I just figured, oh, you gotta subtract it.
That is exactly the right thing. So I'll give you some time to do the subtraction and pick out an answer.
$12.56 H.
That's close. So now when you get the 1256, right? So what you're doing when you do pi times the 800, let me pull up a calculator.
So we have to multiply by 2 then, right?
You have to divide.
Divide.
Right.
Okay.
That's how you got the 1256, right? So when you do this times 800, you're saying to yourself that that is the circumference. But you're correct to do the 1256 because you're only going halfway around the circumference. So if they tell you to go from the entrance to the fountain, that is half of the circle. Right?
Yes.
So you should have the number 1256, but you want to think about what Elise was saying. It was Elise, right?
Yeah.
That the real question again is how much longer is the path from the entrance to the fountain by going around the border of the park? So what they're saying is how much longer is it to go half of the circumference than to just cut straight across? So now this is where you have to say the 1256 minus the 800. Because what they're really saying is you have two choices to get to the fountain. You can go straight across, that's going to be 800, or you can go halfway around the circle, and that's going to be 1256. But you don't want to pick out the 1256 from the multiple choice. You want to say 1256 minus the 800 will be the how much longer. So whenever you do get the answer, you still have to make sure that you go back to the question another time.
So I'm not going to be 456 then.
Right. Yep, it's G. So that was good. You should have the 1256 because you can see what are the numbers there. There's the 2,512. That's the whole circumference, right? Of somebody saying, oh, I'm going to use pi and the 800. And I see that answer, it's J. Then you have the next one where somebody is saying, okay, I only need to take half to go around from the entrance to the fountain. So that person is going to pick out H. But then you have the person who's thinking the how much longer means subtraction. And then you're going to pick G. But when you're doing multiple choice, this is how multiple choice is. I would recommend reading the question like 3 times, especially in a word problem where there's a story part of it. If you read it and you think how much longer automatically means subtraction, you have to remember, oh, I should be subtracting something. Because when you're doing a test, you are moving quickly and you do want to predict where your answer is going to go because of situations like this, where when you start, there's the 2512, right? 2,512. When you take half of that, that's the 1256. And then when you do the subtraction, it's the 456. So because 3 of the answers are in the multiple choice, something like that can be confusing if you're not predicting the end result. Okay, they want me to compare going around the edge versus cutting straight across. So at the end, I know I'm gonna have to do some subtraction. Even thinking that before you start helps you eliminate some of the ones that, like J, where you're going all the way around. And even H, where you're only going halfway around. The real question's about comparing 2 paths.
Okay.
But that was very good that you got to 1256. And with Elise working out what the words mean is really important also. So those are the first 2. Let's take a look at number 3. So a bicycle wheel makes 475 revolutions to travel 1 kilometer. To the 10th of a meter, what is the diameter of the wheel? So now it's telling you in parentheses that 1 kilometer equals 1,000 meters, which we kind of went over really quickly. We might do that again. Use 3.14 as an approximation for pi. So what operation do you think you need to do?
Radius.
So they've got the 475 revolutions to travel 1 kilometer. They're asking you to answer the question in meter. So that's why they're telling you what 1 kilometer equals 1,000 meters. So what they're trying to say is, you should be dividing the 1,000 by 475. So this is a division problem. So when we go to the calculator again, you've got the 1,000 meters, because they went 1 kilometer, divided by the 475. So revolutions are just how many times the wheel goes around. So now you've got this 2.10, and now you're going to divide by pi. So you've got 0.67, but it's telling you to pick something out to the 10th of a meter. So which one would you pick out?
0.07.
Yep, B, right? Well, it's 0.7. But yes, B is what you would pick out. So you have to realize that this one is division. They're telling you how many times the wheel went around to get up to the 1,000 meters. And the only reason they're doing this is to put measurement in it. So really this is circumference because they're talking about a bicycle wheel. And a revolution is the one spin around the bicycle wheel. So now they just want you to convert the 1,000 meters to 1 kilometer. So you're gonna, when you do the division, because they're asking you the question in meter, but they told you the story in kilometer, you're dividing 1,000 by 475. And then you divide again by pi in order to get the diameter of the wheel. So this is like we said before, whenever they give you the total, it's more than likely it's going to be a division problem because they want you to work backwards to what the diameter must have been to start out. And that's similar to the next one because this is kind of like the reverse, but it's telling you what the gears are, and the gears are circular. So this one again, number 4. Consider this diagram that shows a large gear and a small gear. So now you're just taking a look at it again. To consider, the large one has a 5-inch what?
Gear. Radius.
Exactly, right? So just in case, you want to make sure that you recognize that's the radius. So before you even get to the problem, you're on a 5-inch radius and a 3-inch radius. That means you would be saying if you need the diameter, you should be using the number 10 and the number 6. But we don't even know what we need yet. But we have a clue that it's got to do with circumference. So now underneath it says, in the time it takes the large gear to turn 15 times, how many times does the small gear turn?
You going to the store, Chef?
So then you're just going to enter, this is not multiple choice. So how would you figure this one out? How far would the large gear go in 15 rotations? So first you want to say how far would the gear go in 1 rotation?
We multiply 15 times 5.
What should you multiply times pi?
15.
15.
Nope. So you're starting out with the formula. What's the formula?
3.14.
Times what?
Radius square.
No, that would be for area.
Oh yeah, you're right.
3.14 times 10.
3.14 times 10.
Diameter.
Right. So because you're looking for the gear to turn, that's just like the bicycle wheel. We're saying that when the gear turns or when a bicycle makes a revolution, anything like that is 1 spin. Just like from the entrance to the park all the way back around to the entrance again, that would be circumference. Anything that's like just tracing the circle.
We can't hear you.
I think my internet blocked out. Can you hear me now?
Yes.
Yes.
Okay,
Yes,
yeah, I just got a little message. My internet said went out for a second. So anytime that you have any spin of the circle, that is circumference. So what you're looking at is this formula. Circumference equals pi times the diameter. And this is why we're saying when you consider the diagram, you want to really consider it first. So that right from the beginning, you're saying they didn't give me the diameter, they gave me the radius. So now when I'm about to go do a diameter formula, I should be using the number 10 instead of the 5. Just to
Wait,
figure
how do you
out,
get?
because, well, the other one, let me go back to this one. You could do this one. That circumference is 2 times the radius times pi, or circumference is pi times the diameter. So what I was saying when we first did circle, I just memorized pi d because the area formula also has a squaring in it, that I just want to memorize just one thing. So when I remember pi r squared, I'd rather do the r squared than 2 times r, because they're so similar that I think I might, you know, mix them up. So what I do is I only memorize this one, pi times d. So even if they give me the radius, they give me the r, I just double it and use the d anyway, because it makes it simple for me to memorize. So you're looking at the number 5, but in your calculator, what you're really gonna say is pi times 10, which you already know, you don't really have to do this, right? If it was 3.14, it's gonna turn into 31.4. But you can still do it in the calculator. 3.14 times 10. This is how far it goes in 1 revolution. So they're asking you how far is it gonna go if you turn it 15 times? That's when you just say times 15. So you figure out 1 time, then you figure out 15 times. So now what do you do?
You do the same with the second gear?
You could just divide to make it easier for the second gear.
Okay.
But what are you going to divide? That's the question. So let's read the question again. It says, in the time it takes the large gear to turn 15 times, how many times does the small gear turn?
The 1884?
Yes. So what you're going to do now is figure out what is the circumference of the small gear. So that you're doing it in the same way, the 3.14 times the diameter, which is 6, and you get 1884. So this is what you're going to divide. The number that you had before, the 15 spins of the large gear was 471, divided by the small gear, which was the 1884. So that means that the small gear will turn 25 times in that same 471 distance. So this one might have been like a more challenging one. There's a lot of steps to do. First, you have to recognize that you need to use the diameter. So that's step 1, is to multiply the 3.14 times 10 times 15. So you're going to do 3.14 times 10 to get 1 spin, times 15 to get the 15 times they're talking about in the word problem. So that is like 2 steps. Then you do have to figure out what's the diameter of the small gear, which is the 1884. So that's another step. And then you have to divide the diameter of the small one into the total of the large one. So what you're going to write on the grid is 25 times. Oh, any questions about this one?
No questions.
Okay, so then we are on number 5.
Just get a different picture.
A stone is dropped into a pool. The water ripples outward at a rate of 2 feet per second. What is the circumference of the ripple to the nearest foot after 15 seconds? Use 3.14 as an approximation for pi. So when they say, so now this is your imagination again, a stone is dropped into a pool. So most people, you've thrown a pebble into a lake or a river or a creek or a pool. So now when it says the water ripples outward at a rate of 2 feet per second, what are you going to do with the numbers?
You're gonna multiply?
Yes.
Multiply with pi?
First, you're just gonna do the 2 times 15.
Mm-hmm.
And when you get that, so 30, right? 2 times 15 is 30. Is that the radius or the circumference?
Does the circumference?
Nope, that's the radius.
Oh, the radius? Oh.
So if you're imagining, I should have Googled a water ripple. Let's see if I can Google that real quick. So let's see if this one works. Can you see this one?
Yeah.
Yes.
So the idea, what they're saying that you have to imagine is a water ripple, right? So when you first drop it and it expands and expands and expands, that's only going to be in the one direction. So when they're saying from where the pebble drops to expanding, that is a radius. So that's what you have to understand is the 2 times 15 is a radius. So coming back to the question, it says, what is the circumference of the ripple? So what are you going to do with the 30?
Times it by
Multiply by pi.
Let's see. Was that a water ripple? Let me draw it. So you've got a stone is dropped into a pool. The water ripples outward at a rate of 2 feet per second. So you've got a starting point right here. And then you've got a ripple. This is the 2 feet per second. And then they're telling you that it's going to go for the 15 seconds. So basically, at some point, it's a full circle, but it started with just a center, and then it's like expanding, 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 expanding. So what we said is after, if it's 2 feet per second and they want to go 15 seconds, you got 30 as the radius. So in order to figure out the circumference of the whole ripple, you need the diameter again. So you want to say pi times 60 is going to give you the circumference, because from where the pebble drops and then moving outward is only the expansion. When you think that the circumference of the entire water ripple, you're going to now use the number 60 instead. So any questions about that? This is another one that really, you need to use your imagination for, because they're just describing it. So you have to say from the pebble is the center of the circle, or the stone in this case. And that's the thing that you have to remember is when you drop it in, you're really creating the center of the circle. So when the ripple starts to move out, that's just from the center outward as a radius. So the number that you actually need is 60 times pi. And they're using 3.14. So it's 188.4. So you would be picking out D for that one. So any questions about that one? And sometimes things are like this, like on a high school test, especially for adults, right, taking the high school test. They're saying that you're already at the senior year. So a lot of things, if it's like a stone dropped into a pool, or even sometimes the ones about gravity, if they're saying you're hiking and you drop your sunglasses, or Those types of things are based on prior knowledge that you might have done that already. So that you understand, if you've ever done like skipping rocks or anything like that, that you're really hitting the center of a circle when you drop something in the water. So you do need to, this is why, again, like the math is still reading, because just like when you're reading, you're doing the who, what, when, where, why, how, or you're doing sight, sound, smell, taste, touch. You're thinking about what the words, what the images that the words are creating for you, so that you even have context of what they're talking about. Because just using the numbers like 2 and 15, let's see what that one would be. So that 94 is just the 2 times 15 times 3.14, right? So sometimes just trying to use the numbers that are in the problem is going to give you one of the answers, A, B, C, or D, but just randomly picking an operation for them is not the right answer. So you would have really needed not even just the 30 for this problem, you need the number 60 for this problem. If you did 30 times 3.14, that's B. Let's see, what else could we figure out? 47 is just the 15 times 3.14, right? So a couple of times, if you just pick a number and you start multiplying or start dividing, you're going to get one of the answers, because that's how the test is designed again. So what you have to do is really be imagining and aim to predict a little bit, so that you can say to yourself, there's a big difference between the 188 and 47, right? So you want to say to yourself, what am I really looking for? I'm not looking for the ripple, which would have been a radius. I'm not even looking for the diameter. I'm looking for the whole circumference of the ripple. So maybe I should be looking at a higher number and maybe making a guess out of the C and D even, as opposed to picking the A or the B. But you're only going to do that if you're predicting and thinking about the actual words that they're using. And in this case, they're saying stone is dropped into a pool. That stands for the center. The ripple, the water ripples outward. That stands for the radius. So you have to kind of draw those conclusions yourself. The only vocabulary word they have in there is circumference.
Okay. Rank it.
So how do you think you did with the circumference? More or less. Now you can come back to this and do the math is fun again, just to practice using the formula. And you can also go to the study jams. So I'll put that on Google Classroom so that you can have something to go back to. So in study jams, there's a geometry section. So I haven't really assigned these because you did Khan Academy, and I know some people have completed Aztec, that first section of geometry and the Pythagorean theorem. But if you want to do the interactive activities, I really think that study jams is good because it's very interactive. So let me see. I have to figure out which one it is that really goes into a circle. But what I'm going to do is I'll post that on the Google Classroom as an option so that you can review Math is Fun if you want to. Of course, you can go back and look at Aztec and Khan Academy. We've already done the introductions to those. Now this next section is going to be area. So now this is the one where you're picking out the next formula, which is the one I was saying. This one down here, A equals pi r squared. So now you're looking for the radius all the time, as opposed to looking for the diameter. If they're talking about how much space the circle takes up, if they give you the diameter, you have to cut it in half first to get the radius, and then you have to square it. So what I would do is I would always write down the formula, A equals pi r squared, and then see what the information is that's in the word problem. So if we look at this first one, it says, what is the area in square inches of a circle whose diameter is 22 inches? What would the answer be?
Inches. Would it be? Got it wrong.
Would it be G?
It would be G, right? So this is one where when you look at F, G, H, and J, pi is still in all of the answers. So what they're really asking you is, do you understand to cut the 22 inches in half and get 11? And then do you know what 11 times 11 is?
Mm-hmm.
So this is one where you don't need the pi symbol, you don't need 3.14. What they're saying is the answer will be 121 times pi. But you have to understand how you got to 121. So now some people might say, let me cut that in half, and that's 11, and they're ready to pick out F, right? But you have to remember that it is the radius squared, which is 11 times 11, and then you're gonna pick out G. So again, if you start with the formula, A equals pi r squared, and they tell you the diameter is a 22, you're automatically saying, I need a R, which is 11. And then r squared would be 121, and then I don't need to go any further because all of the answers still have pi in them. So I'm picking out G. So this would be an example of one that would be very easy. You should be able to do this one in less than a minute because you know the multiplication table. So where maybe like the one with the gears, that's like 5 steps, that might take you the whole 2-3 minutes, maybe even 4 if you have to read the question a couple of times. But one like this, you're supposed to get in less than a minute. So it's balancing out the test. Just like we said, what are you gonna paint the wall in? Cubic inches, cubic feet, square feet? You're supposed to say square feet. That makes the most sense. And that's one that is less than a minute again, right? So now we're gonna just take a look at this test taking tip, and then the rest of these are gonna be for tomorrow. So let's just take a look at this one. It's easy to confuse the radius and the diameter of a circle when making calculations, since both are used to solve problems. The diameter or radius can be used to find the circumference. The radius is needed to find the area. Note whether you are given the radius or the diameter, and if necessary, convert from one to the other by multiplying or dividing by 2 before making calculations, right? So this is what we're saying that you have to do. This is why some of the time you're saying consider, or you're reading the problem more than once, right? And this is also why I'm saying to do circumference, I'm on pi times diameter, so that I can leave radius and squaring to area. But you can do this however you want. What you want to say is you're going to do it the same way every single time. So I'm using the diameter to find circumference all the time. And I'm leaving the radius for area, just to make the separation in my mind. But the part about noticing what you're given is very important. So you should do all the considering and do all the noticing first. And then make the adjustment. Like they said, if they give you the diameter, and you're on area, you have to divide by 2 before you make any further calculations, because you'll end up confusing yourself trying to use the numbers that are in the problem and the numbers that you really need. So let's see how many there are. There is 7, 8, 9, 10, 11. So another 5. We'll do these tomorrow morning. So what you want to do is, we're saying maybe take like 15 minutes and do 3 minutes per question. if you want to do that now and just maybe like work up until 11, if you can get the answer, you're going to write the answer in or select the multiple choice. But if you don't get the answer, you have to come up with a question. So tomorrow we will break up into the small groups and talk out the problem for the 3 to 4 minutes. You can just say what you did, or you can say the question that you had, and then we'll come back together. So these are, again, like the most challenging questions, because this is not even the textbook. This is the TASC exercise book. So if you feel like you're getting these right, that's a good thing. If you feel like you're getting them halfway right, then what I would say is you probably have the math down. And what you want to do is just reread the question and see what they're actually asking you. Because this is more like a puzzle, you know, like this is more processing information, eliminating things. More than any other subject, math is really like that, but it's still heavy on the reading. So how many people eat sushi?
Me.
Just had some sushi yesterday. I don't eat any fish, but I had avocado, the avocado sushi roll. So sometimes they have the avocado cucumber. Right?
You did it yourself?
No, I went to the grocery store. So at Whole Foods, they have a little sushi bar. So I picked up a little package, 2 rolls. Well, actually I got 4, 2 for my daughter and 2 for me.
Okay.
So I do make them though, but my roll is never as tight as the chef. So I have to practice. But this is, you know, background information that's not necessarily needed. It's helpful if you're thinking about sushi, but it's not really needed, right? So this is part of the storytelling that says a chef has been preparing sushi on a circular table. All you have to think about is a circular table, but the chef and the sushi are extra, right? So when you're thinking, I have a circular table with a diameter of 15 inches, that you should be imagining that diameter is cutting through the whole thing. This is where you're imagining what you drew or what you saw on Math is Fun or what you put on, you know, the computer, but you're imagining when you read the word diameter, that's the whole thing straight across. So now she decides she needs a table with at least twice the area of her current table. So now that you know that you're in area again, you should be thinking about, I need the radius. I don't need the diameter. I need to cut the radius from the diameter and say it's 7.5. But now back to the question, what is the minimum diameter of her new table? So now this is where you're going back and forth using the formulas to get to the question they're asking you from the information we gave you. So you have to figure out what the diameter of her table is.
I don't know.
Voice went off again.
Can you hear me now? So you have to first figure out what the diameter of her current table is. Then you have to double it because it says she needs a table with twice that area. And then from that area, you have to come back down to what is the diameter of the new table. So this is how you're going to get something that is, you might be using area, and then you have to multiply, and then you have to, you know, find the radius again, and then find the diameter. So you're going up and down or back and forth or in or out, however you want to describe it. This is how they can give you one question and make sure that you know multiple formulas. So like we said, you just want to read it, spend like the 3 minutes or so, because there's 5 questions. Even if you spend 4 minutes, you don't want to do more than like 20 minutes worth of work, right? If you feel like you're not getting the answers, then you want to just go back and look at that section on Aztec or redo this section of Math is Fun. So what I'm going to do, we already did this. If you already did it, you don't have to do it again. But I'm just going to list it in the Google Classroom to make it easy for people who didn't attend this class to just be able to find out where things are. And then I'll try to find the one that matches it if I can on Study Jams. I think you have the formulas already, and it sounds like you have them down. So the harder thing is going to be just really thinking about what the word problems are asking you to do. And you can, you know, draw this out too. You drew a circular table. You need one that's twice the area. So that's a times 2. When you read something like the word twice, that's back to your algebra. That just means I should multiply by 2. So that's it for today's class.
Mm-hmm.
So what I still have to do is put up our discussion picture or video because I didn't find that yet. So for now, we're just doing the 20-ish minutes on area of a circle. And then tomorrow there'll be something up for us to watch a video or take a look at a graph or take a look at a photo just to analyze. And then we'll keep going through this circle page. Any questions about that? Now, if you have a question while you're doing it, you can text me still.
Okay.
If you're in the middle of working it out, and I can give you some, you know, if you're in the mood to do that, right? So I'm saying 3 to 4 minutes just to say it's another 20 minutes of study. Some people you might do more than that because you might go back to Aztec or you might go back to Math is Fun for a little review.
Bangladesh está con tos seca, dice, con fiebre.
If you want to say, hey, I'm working on number 7 and I think this is it, and you want to ask me a question, you still can. And I think that what I'm going to do is I'm just answering your questions live, but I'll also come up with like office hours if you want to do like another Zoom or you have another question. So I'm going to pick a time of day or a day of the week, you know, and just have kind of like an open, you can pop in if you want to.
Okay.
So any questions?
No, no.
Thank you.
No.
All right then. So then I will see you tomorrow. Have a great day.
You too.
You too. Thank you. Thank you.
Bye.
Bye. Have a great afternoon.
Bye.